9 today.
So it's a prequel, gang.
Because I won't be here period 9 because I'm going to see my daughter's little presentation on China. Yes. Yes. All right. So I'm going to minimize this. Oh, sorry. So basically, we're talking about, and you guys, you don't have to write this down. If you'd like to, you can. You could go in the front of your packet if you'd like to. But I'm just going to kind of talk a little bit about fractions. Basic fractions first.
I like fractions.
So, when are fractions undefined?
When they're over 0.
Yes. So, a fraction, and you guys know this, is undefined when 0 is in the denominator. Right?
Right.
So 1 over 0, right?
That's illegal.
It is illegal. Negative 2 over 0.
That's illegal.
What about, they'll get a kick out of you, RTV. What about 0 over 10?
That's just 0.
That's just
Edit
0.
this or no?
No,
That's
it's raw, unedited.
Wow.
Yeah.
Doesn't go in there and drop it out.
No, I don't. All right, so we all know that, okay? Now we need to know how to simplify fractions. So simplify fractions. Take something like 4 over 10.
Well, that's just 2/5.
Right, that's 2/5. Now, why is it 2/5? Yeah, well, technically what we're doing is we're taking the 4 over 10 and we're finding the factors of 4, which would be what? 2 2's, right? I would go with 2 2's because 2 goes into 10, right? Instead of 4 and 1. And then 2 and 5, right? So what you're doing really, even though everybody does this, right, is we're breaking it up into its factors and then canceling like factors because 2 over 2 reduces to 1. Yes, but
No, but I see where she's getting here.
we need to understand this in order to understand where I'm going today.
Where are you going today?
You'll see. No, with the lesson.
Okay.
So you take a fraction and you cancel and reduce like factors. We also need to know how to multiply fractions. So something very simple like 3/4 times
5/12.
5/12. Okay. Now, how would you guys do this? Or Jimmy, go ahead.
Well, you simply multiply the numerators and you multiply the denominators, and then that would give you 15 over 48.
Good. And then what would we do?
Then we would probably simplify it if we could.
Right. Let's do the factors. What's the factors of 15? 3 and 5, and then 3 and 16. And what's the like factors here? 3's cancel out, and we get 5/16. Now, again, a lot of us just would have went, but I'm doing this step on purpose. Now, what we also could have done, just so you can see where I'm going to, is we could have done 3 times 5 over 4 times 12 and written it in one big fraction. And then we could have done 3 times 5 over 2 times, oops, no, actually, yeah, well, 2 times 2 times 3 times 4, right? I don't know if you'd really want to do this, but then only to see the like factors that cancel. So what's the only thing that actually cancels? The 3's. And then again, what are we left with? 5 over 16. But we don't think of basic fractions like this, and we need to, okay, for what we're going to do today. And the last thing that we need to remember how to do is, whoops, I thought I hit the plus sign. Multiply. Divide fractions. Now, how do we divide fractions?
Well, you just apply a little bit of that keep, change, flip stuff, and then you just multiply them like normal.
Yes, keep, change, flip, right? Wait, you want to give me another one? That was a good one
Okay.
before.
4 twelfths, we'll say 12
Okay,
times.
not too big.
Do you want the same?
No, I want divided.
Okay, 5 6.
All right, good. All right, 4 twelfths divided by 5 6. So as Artemi said, and I think that's how a lot of, like, your 6th grade teachers always, right? Because that's when you really learn fractions a lot, right? I feel like 6th grade. Keep, change, flip. I mean, you learned them before, right? But keep, change, flip is the kind of cute way to say, what do we do when we divide fractions? We really multiply by the reciprocal. Excellent. So you take the 4 twelfths and you multiply by 6 fifths. Okay, and now we're back where we started from. We can multiply across to get what? Over 60. Ooh. Break it up into its factors.
12.
Yeah, 12 is probably better, right? 2 times 12 and 5 times 12. And what cancels? 12s. And when I say cancels, I mean reduces to 1. Big difference, because sometimes when you say cancel, that means goes to 0, but no, it goes to 1, not 0. And then I'm just left with 2 fifths. All right. Do you feel like you were re-educated in fractions a bit? Okay. Now, where are we headed to? Algebraic fractions. Now, these algebraic fractions differ from the ones I just did because they have x's in them. They're also called rational expressions, and we've been working with rational expressions a little bit in the beginning in this unit. So, rational expression is just a fancy word for algebraic fractions. Okay? So, now, hop over to lesson 5. Lesson 5. Now, again, I'm going to be jumping all over the place. The what questions?
The question, you pushed the question to the last one.
What are you talking about?
The last review sheet, like the last one we did. Right?
I did.
Okay.
Why? You didn't check them?
No, I was just wondering.
Oh.
I didn't know if I did it.
Yeah. And then we went through a lot of them in class. Okay. So, all right. Now, this question says, find all values of x for which the rational function, why are they calling it a rational function instead of a rational expression? Because it's h of x. Is undefined. Verify by using your calculator to evaluate this expression for these values. Okay, so when is a fraction undefined?
When the denominator is 0.
When the denominator is 0.
Just take the undefined, the denominator, set it equal to 0, and then find the values of x.
Yes, that's it. So the numerator doesn't matter. You want to know when the denominator is going to be equal to 0. So what do we do? Factor. Yeah, you could do quadratic formula, but I would try factoring here. So it would be what, guys? 2x and x. Can the 6 go with the 2? And then 1. Will this work? 6 and 1? Because what am I getting? I'm getting 12 and 1. Will that give me an 11? Yeah, but I need a positive 11. So where is that going to go? Yep. Excellent. So now, x is going to be equal to 1/2, and then x is equal to -6. Now I want you guys to take your calculators right now and pop that into your y equals. We talked about this in the beginning of the year when we did the unit on functions. Now, these algebraic fractions, or these rational expressions, create funky graphs. Now, why do they create funky graphs? Because they're fractions. And remember, you can't have a number that's going to make it 0 in the denominator. So then your domain gets restricted. And so whenever your domain gets restricted, it creates breaks in the graph. So can you guys just tell me what it is? I would suggest using alpha y equals. That's much easier. Can you tell me what that was? X plus 5?
X plus 5 over 2x squared plus 11x minus 6.
2x squared minus 11x plus 6?
Minus
Yes.
6.
Oh, minus 6?
Oh, well,
It's plus 11x or minus?
Plus
Minus, oh yeah, plus x.
Oh, shoot. Totally messed that one up. All right. Zoom 6.
how'd you get
Oh,
like
whoa,
an asterisk
what's this?
calculator? Yeah, like I just did that. And
You mean like a...
it said like error, and I looked up and it was like a little asterisk thing, and I just had to look through and I got it.
I don't know either. All right, so what values weren't allowed in the denominator? 1/2. Do you see right here? Where's that? Oh, this thing is so annoying that I can't write on it anymore. I have to do this. Okay, you see this right here? What was that called again? Asymptote, yes. The function approaches it, but will never cross. So it goes as close as it can to 1/2, and then it never reaches 1/2 and picks up a little bit bigger than 1/2. And then what about on this side? Is an asymptote where? -6. So again, it's going to go as close as it can to -6, never cross it, and then pick up down here and go. Actually, it actually goes the other way, but it's fine. So you get the idea, right? So whenever you have these rational expressions, you're going to create these breaks in the graph. And why? Because you can't have 0 in the denominator. So let's do another one. Whoops. Where's the next example? This one. Okay. Which of the following represents the domain of a function? Okay, so now this is a good question too, but it's asking it slightly different. So, does this one have choices? Yeah, okay. So, the idea is, domain, you remember, is x, right? So, can I input any values into this for x? Or would there be restrictions? And where would the restrictions be? The denominator. So how do you find the restrictions? Set it equal to 0. Yes. So I'm going to take x squared minus 6x minus 16, set it equal to 0, and that's going to help me find my restrictions. So what do I get here? X and what are you getting? Minus 8 plus 2. Do you guys agree with Justin? Okay, so one restriction is, yes, 8 and -2. Okay, so now, how would I write this? Do they have it down there? Yeah, so this is, this set builder notation. Which one is it? This one, 3, yeah. So you could write all real numbers except 8 and -2. You could write it the way they did too. You could also say all real numbers, but x can't be -2 and x can't be 8. That's another way to write it. Okay? So the rest of this lesson, if you just flip with me, is a function composition, which is review, and inverse, which is review. So I'm flipping. So now I want to go to lesson 6. I'll probably give you some review homework to do, but I want to get to the new material. So now lesson 6. Like I told you, I'm going to be jumping around here. All right, so the front of lesson 6, we've done these when we did, when we talked about exponents and how to simplify these. So these, I'm not doing either. Flip to the back.
What's a teenager post today?
What does what?
Teenager post?
Oh, I don't even know what this is. Teenager post things I never learned in high school. How to pay bills, buy a house, apply for college. But thank God I can graph a polynomial. That's actually kind of funny. All right. Ready? Okay, so here I am. Everybody on the same page? So, this is a fraction, and all we do is simplify it. So how do we simplify fractions? We factor them and cancel like factors. God bless you. Exactly what I did at the beginning of the class with numbers. And that's the way that's why I did it that way. So,
Bless you.
lots of sneezing in here. All right. So, how do we factor this? X and X. 7 and 2. Plus 7 minus 2. How do I factor the bottom? X plus 2, X minus 2. If factoring was hard for you, this is going to be hard for you. Because it's all factoring. That's all we're doing is factoring. So, now, the only thing you can cancel are like factors. Just like in the beginning of the class, the only thing I canceled out were 3's and 2's because they were like. These are like 3's and 2's because if you input a number in for X, it's going to be the same number. So technically you're doing the same thing, it's just in terms of X. So the only thing I can cancel out here are what? Yes. And so the answer then becomes what? Yes. Now sometimes kids in this, when they learn this, they go canceling happy. And they're like, oh, I see X's, I can just cancel those too. And you can't. Because just put a 1 in there and a 1 in there. 8 over 3, is that the same number? It's not the same factor then. So you stop here. This is it. Okay? I like to say if it's in a set of parentheses, you can cancel it. You create the parentheses though. Let's do this one. How would you factor this one? Dots, 2x plus 1, 2x minus 1. Bottom, GCF, yes?
5 times 2x minus 1.
Now, what's your only like factors here, or factor? 2x minus 1. Now notice I put little 1's there, because they are canceling to 1, not 0. And then what am I left with? Done. See, aren't these fun?
Yeah.
Really, right? So you cancel and you factor, that's it. If you don't know how to factor, you're not going to like this unit, but I'm sorry. It is what it is. All right, so 3x and x, what are my numbers?
4 and 2.
4 and 2, 4 and 2. And signs? Now guys, with these questions too, because the goal is to get all factors to cancel out, could you have factored the bottom first to help you factor the top?
Sure.
Yeah, you can cheat that way. Because if you were like, oh, I know these factors, so one of these probably has to be either one of these two factors on the bottom. So it can help you sometimes. So the x plus 4's cancel. And then what am I left with? 3x plus 2 over x minus 4. Okay. Now, exercise 5. Bring brings up a very important idea here. And we want to look at, well, what happens if we had x minus 5 over 5 minus x? Does that equal 1? No, I mean, you can see that, right? Because this is positive and this is negative. This is negative. Excuse me, that's positive and that's negative. So they're clearly not going to cancel to 1. But do they cancel to something else?
Yes.
What do you think? Negative 1, yeah, they do. And this kind of shows you that. Because these are all opposite factors. Opposite factors always cancel to 1. They reduce to 1. So look, this would be 3 over negative 3, which reduces to negative 1. What would this be? 12 over negative 12, which reduces to negative 1. Now, this, then clearly we know is negative 1, right? If you like, you could factor out a negative to, like, see it. If I factored out a negative, this would have to be negative, the b, right? Yeah, and then this would have to be a positive. I'm just showing you, like, how it works. And then you, oops, sorry. And then you see clearly how then that if I just rearrange it, those are then now the same factors, and I'd be left with 1 over negative 1, which is negative 1. But do I have to go through all those steps? No. You could just see opposite factors, no, they cancel to negative 1. Now, another thing that comes to mind when I just taught this, when a fraction is negative, it could be on the top, it could be on the bottom, or it could be in the middle. But in order for a fraction to be negative, it has to have 1 negative. If it has 2 negative, it's positive. Just keep that in mind, too. So now let's look at this question now, exercise 6. So 2x minus 10 over 25 minus x squared. Now, remember when I taught factoring, and I said if the order was flip-flopped, never rearrange the order, just keep the order? Okay, so how do we factor the 2x minus 10?
2 times x minus 5.
And bottom is?
5 minus x, 5 minus x.
Now, you should say, oh my God, I see something here. What do I see?
Oh my goodness gracious.
Yes. Do you see opposite factors here? So, what are they reduced to?
So if you just do negative 2 over 5 plus x.
Yes, negative 1. Now, where do you put the negative? Anywhere. Like I told you. Top, bottom, middle. Where does it usually go? The top. Yeah. So I will always put it to the top. But no, in like multiple choice questions, your answer could be in the bottom, like your negative could be in the bottom, but the multiple choice question, the negative might be in the top. So you have to be comfortable manipulating that. Yes.
Just like factor out a.
You could. You totally could from the beginning. Like from here. In the beginning? Yeah, you can, Justin. So I usually go like this. Negative 1 on top, and then this 1 on the bottom. And then I would get negative 2 over 5 plus x. And done. What do you think, guys?
The issue is there's no answer choice like that.
There isn't?
There is.
It's 1.
Yeah, it's 1. I didn't even know this was multiple choice.
I don't know, it's x plus 5 though.
Well, is x plus 5 and 5 plus x the same thing?
Yes, okay.
Just remember the commutative property,
Blake.
Blake.
Yes, commutative property. Yes. Don't
Got it.
stop. But yes,
How much
that's
do I start?
that's actually no. That actually it's a good point. Is 5 plus x and x plus 5 the same? Oops, shoot.
Okay, how much do
All right,
I
let's do.
start myself right now?
0 times, please.
All right, guys, let's do this one. X squared minus 6x plus 9. How do we factor that? X and x. Oh yeah, sorry. And then, what do you see again? Opposite factors. So, again, this will cancel with this. I always put the negative on top. Most of the answer choices do that as well. And then now look, you have a decision. You have negative x minus 3 over 6. Now you can perfectly, that's fine to leave it like this, or what else could you do? Negative x plus 3 over 6, right? Or you can flip-flop that, which a lot of times they do. 3 minus x over 6. Now, I don't even know which answer is there.
4.
Okay, so they went here. Okay. All right, so how are you guys feeling so far? Not bad, right? It's pretty simple. Okay, let's go multiplication. All right, multiplication gets super, super duper fun. Oh my gosh, I love it. Now again, I'm not going to do these types of questions that I feel like, these are like the baby questions. I don't want to do the baby questions. I want to do the bigger questions.
Okay.
So questions like exercise 2, lesson 7. Right here, you with me?
Oh, yeah.
So 2C. Oh, actually, should we do B? Is there a 1? Is 1 not babyish? All right, let's do this one first. Let's do 1. And I'm not going to do this because I did this in the beginning of class. So I'm going to move that up. All right, so I'm doing B. Okay, this is the question I'm doing right now. Now, boys, stop talking. So I have 2 rational expressions being multiplied. Now, this might look intimidating, but it's not. All you do is factor. So you factor and cancel out like factors. So, here I go. I'm going to start with the first fraction. Top left. How do I factor that? How do I factor bottom left?
2 and 3.
X and x.
And then something 2, something
2 and 3. What are my signs? Plus 2 minus 3. Okay? Now I pop over to the right fraction. What do I factor out on the top? 3x. And I'm left with good. And on the bottom? And I'm left with, okay. Now, you know how we multiply fractions across? So now technically, this becomes one big fraction where the only thing I can cancel out are like factors. What am I, oh, there's a plus 2?
Yeah, the top left thingy.
Oh, thank you. Justin, were you going to tell me that?
No, I was gonna say, can you cancel out 4?
No. You cannot cancel, no. This is why I'm factoring everything, because you can only cancel stuff out when it's in terms of its factors, just like I did in the beginning of the class. So you have to break it up into its factors, and then you cancel like factors. Otherwise,
What's on the top left, like x plus 4?
no. These x's?
No, it's like right below that.
Oh, yeah, right here? Yeah. I was just wanting to show you what's going on, and now you can cancel stuff out. All right, so what do you cancel? X plus 2's?
Yes.
What else do I cancel? X minus 2's? What about the x's?
You can make 1 halves. something like that.
No, these are attached by multiplication. What's x over x? Can I cancel it out? Yep.
3/6, could you make that into 1/2?
Yep, the 3/6 you can make into 1/2. And is there anything else I can do here? Doesn't look like it. So then multiply across all ones except for x plus 5. And then 2 times x minus 3. Or you could do x plus 5 over 2x minus 6. I believe that this is a better answer because it's completely factored. But sometimes you'll see it like that. Aren't these fun? Yes, Sammy. I didn't cancel. So x over x I canceled to be 1. Because just think of if x is 5. 5 over 5 is 1. 2 over 2 is 1. And then 3/6 is a half. No, you can ask.
No, I don't even know if I'm saying it's point anymore, so.
Okay. All right, let's try another one. You can see another one. Let's go 2c. Want to do 2c?
Sure.
2c. Okay. Gonna move D. You need a lot of room for these. So, if you factor wrong, can you get this question wrong? Yeah, that's like that. That's the only thing that's the bad thing. When you factor wrong, it's not good. All right. So let's go. Factor, factor, factor. How do you factor top left? Top left? 2x and x. Yes? Oh, really? Oh, which one do you have?
What? 2x squared plus 12x.
Yeah, can I see it? Hold on. You don't have the same one as me? Exercise 2? Did they change it? Because this is exercise 2, right? Oh, is this the same question? Oh, all right. Is this that question or no? Oh. All right, let's make it up then. I mean, I'll use yours. I'll just read here. So what is 2c then?
X squared plus 12x, 4x plus 8.
All right, I have it right in front of me. All right, so you guys start. Okay. Sorry about that. I don't know why that's like that. So, what do we factor out? 2x, and what am I left with? X plus 6. Bottom, what do I factor out? 4, and I'm left with?
That's my problem. Cross that out.
Here? Top right? X minus 6, X plus 2, good. And bottom left? I mean right? X plus 6. Okay, now, you know how I wrote it as one big fraction before? You don't have to do that. It's really just like connecting it and then crossing out. So, what cancels? A lot. X plus 6. Remember to put your 1s. X plus 2s. Oh, look at that. X minus 6s. Oh! 1/2 x. Beautiful. I love when they cancel like that. That's so rewarding. All right, let's do division, and then we'll be done. This is all very similar. So this is why I know you guys can handle this. Division. All right, tell me if this is your, 3C, is that correct? Okay, all right, so we're gonna do, yes. So, now, my suggestion is to flip it right off the bat, so you don't forget. So, the only new material in division is that you multiply by the reciprocal. So, what I would do here, and when you start to get used to these, some kids just flip it and factor at the same time, but in the beginning, it's probably best. You always keep the first fraction, change the sign to multiplication, and flip the second fraction. And now this is exactly what we just did. No new material. So the only new material is changing the sign to multiplication and flipping. That's it. So now it's a multiplication problem. So talk to me. How do I factor top left? X minus 2 plus 4. Good. How about the bottom? Minus 2, God bless you. What do I factor out here? 2. And then bottom? Good. Now we cancel. Again, if you want to connect it, it's one big fraction.
That's not very rewarding.
This is a rewarding one too?
No, it's not.
Oh, it's not? X plus, yeah, I guess not. There's not a lot that cancels here. X minus 2's. But the 2/8 goes to what? 1/4.
I guess it's not bad.
So it looks like, what am I left with in my numerator? X plus 5 over 4 times, yeah. That one's not so bad. All right, and let's do D, which I think I moved D. Let me move this guy. Here we go. So here's D. And then we'll call it a day. And I'll give you, I'm not going to make you do all 3 homeworks. I'm going to pick for you guys to try. Because honestly, in everything I just taught you, the only Regents question that you'll see is when is this fraction undefined? The other topic is what we're going to be doing on Monday. And that's it. All right, so let's factor. How do I, oh no, do you want me to flip first? I usually, but since we're new at this, I usually factor and flip at the same time, but don't forget to flip and change the sign to multiplication. All right. Okay, so what do? Help me. One last one here. Numerator? Yep, got a dots in the numerator. Tricky try. 3x and x. Plus 1. Plus 2. Yep, that looks good. How about here? X minus 7, x plus 2, good. Ooh, we may have a little opposite factor going on here. 1 minus 2, we have an opposite factor. We do. Be careful. Okay, so you connect them, one big fraction. So let's cancel here. Hold on 1 minute. So let's do the opposite factors first. This would cancel with this, and where do I put the negative? Yes, suggested on top, 1 negative. You can put it on the bottom if you'd like, but I usually put it on top. What else cancels? 3x plus 1s. What else? X plus 2s. Anything else? No. So what does it look like I have?
X plus 6.
Negative x minus 7, don't forget the negative, over 5. Now, you could distribute through with the negative, and then flip that around, because they always do that. Those are all the same. However, I feel that this is the best. You don't have to go further from there. Okay? So, have a great day. I'm not going to give you all 3 sets of homework, because we did 3 lessons. I'm going to give you a few questions from each, okay?
All right, keep time with the time.
All right. Have a great day. Have a good weekend. They're gonna